Okay, so welcome to this video tutorial, and today we'll be talking about subnetting. So basically we are doing a network security question for cyber security first year. It was our test 2, test 2 question. So it's question 1D, which says you are the new network administrator from Lakupikwa Secondary School and just discovered that the network is using a /24 mask. You since embark on subnetting the network using VLSM. Assuming the central admin has 17 members of staff, students are 120, and general admin has 43 members of staff. Show the implementation that will employ efficient use of network resources if the IP address is that. So what I'll do is that I'll teach you different methods on how to subnet. So after doing that, we'll apply this question in Cisco Packet Tracer because I cannot start drawing on my PC, so I'll do it in Cisco Packet Tracer. So first thing, the method I'll show you is the method I usually use. The one is more like I've created it or something like that. So if you watched my previous video, we said if you are given a certain IP address like that one, so you need to ask yourself which class does it belong to. So that is a class C. How can you know if it's a class C, class A, class B, D, or up to E? So a class A, basically an IP address which is a class A can be written in this format: 255.0.0.0. Then a class B can be written in this format, which is 255.255.0.0. Then a class C can be written in this format, which is 255.255.255.0. So that's how we can tell if it's a class A, B, or C. So those are the most common classes they usually use. So so that's how you can understand the class of a certain IP address. So now let's try to explain some few stuffs. So as you can see, if you are given a subnet mask which has .0 at the end, it means it's /24. So what is a slash and how do we know, and what is a mask? So basically a subnet mask is this format or a way you can represent an IP address. Then a slash basically will tell you the number of ones in the network. So this portion which is highlighted is what we call a network portion in a class C. Then this portion which is just a .0 is what we call the host portion in a class C. Then a slash which is /24, it means we have 24 ones in this network. And how do we prove that? So first of all, you need to understand that if you convert 255 into binary, whereby 2 is base 2, 255 is just the number, and R is the remainder, you notice this. So let me just open up my calculator, then let's start. So we have 255 divided by 2, which is 127. So 120 it's 127, then the remainder, as you can see, it's 1. Again, if 2 is divided into 127, 2 divided by 127 divided by 2, so 63. So we get 63 remainder 1, and 2 into 63 is 31 remainder 1. 2 into 31, it's 15 remainder 1. 2 into 15, it's 7 remainder 1. And 2 into 7 is 3 remainder 1. 2 into 3, it's 1 remainder 1. 2 into 1 is 0 remainder 1. So if you count the ones starting from the bottom going up, it's 1 2 3 4 5 6 7 8. So if 255 is 8 ones, 1 2 3 4 5 6 7 8, so that IP address can be represented as such. So as you can see, this portion which is the network portion, has 24 ones, because 8 times 3, it's 24. Then this 0, once converted into binary or represented in binary, there are 8 zeros, because this subnet has 32 bit. So you can see now why it's /24, because the number of ones at the network portion itself just 24. So no wonder it says /24. All right, so now that you understand some of the basics, again what you need to understand is that there is what we call static subnetting and static subnetting, which is called classful subnetting, or classless subnetting, which is also called variable length subnet mask, which is VLSM, the one you're doing right now. So now under static subnetting, this which is the slash or the subnet mask does not change, no wonder it's static. While in VLSM, this slash will be changing depending on the number of devices will be needed to be assigned on that particular network. So in our case, we have that information about Murakupikwa Secondary School. It's the one you're trying to subnet to give it different slashes or subnet masks. So now that we do understand that, let's come up with a VLSM table using the first method that I usually use. So VLSM table, you need to understand that there's what we call a block size. There's what we call a block size. Then there's what we call CIDR, I'll explain, and a subnet mask itself, at least you know about that. Okay, so basically the block size starts at 1, then CIDR starts at /32, then subnet mask starts at 255. So now here's the thing, a block size will help you to know the number of subnets and hosts that can be assigned to that particular network. Say an example, a block size of 1 can assign no IP address. Why? Because under IP addressing, there's what we call a network address and the broadcast address. So a network address and a broadcast address must be subtracted from a certain range or a block size. So a block size of 1, if we remove 2 for the network and block size, we get -1, meaning there's no IP address we can assign. Therefore, you cannot use, or you can never use, a block size of 1 or CIDR of /32. Now, coming to CIDR, CIDR basically means the number of ones in a network. So because it's /32, this means that we need to have 32 ones in our network. just like that. So that's the meaning. Now coming to the subnet mask, uh, if you can remember, when we converted this 255 into binary, we are getting these ones. So this is how it can be represented in binary format as the subnet mask. But to represent it in a normal way, it's 255.255.255.255 or /32. So that's how you can represent that. So now that you understand some of these basics, now let's create the VLSM table in a simpler way without making it complicated, and we'll be doing it fast so that we go to the next method. Okay, so for the block size, what we usually do, you just need to multiply it by 2. Then for the CIDR, you subtract it with 1. Then the subnet mask, you need to subtract it with the top block size. So I'll explain everything, don't worry. Yeah, so 1 times 2, it's 2. 32 minus 1, that's 31. 255 minus the top block size, which is 1, it's 254. 2 by 2, that's 4. 31 minus 1, that's 13. 254 minus 2, which is now the top block size, is 252. So I'll pause the video and then continue doing that same procedure till we finish. Right, so once you reach at 128, under block size you just need to put a 0. Then 25 minus 1, we know it's 24. Then 128 minus the top block size, which is also 128, so again it's a 0. Now no wonder if you can see a /24, which is this, has a dot 0 at the end, as a dot 0. So it means if we have a /27 at the end, we need to have a dot 224. So I hope you understand that. That's how I come up with the VLSM table. Now let's follow up the question, then we'll see another way on how we can come up with this information that you're just talking about. For now, let's follow the question now. Okay, now as you can see from the question, students are 120, general admin is 43, and central admin 17. So under subnetting using VLSM, we start with the biggest network, such as students, because it's 120, followed by general admin, last 3 central admin. So first thing you need to consider is the block size. So the block size from our VLSM table, you already know it. Which block size can accommodate 120 members? As you can see, 128 can accommodate, because if we say 128 minus 2 for the network and broadcast address to know the number of hosts, it's 126, meaning 120 can be accommodated into 126. So we'll say block size is 128. After knowing that, we need to know how many valid hosts can be variable. So it's block size minus 2 for the network and broadcast, which is giving us 126. Now by knowing that, we need to know the subnet mask. So the subnet mask, as you can see, this was the subnet mask. So now that subnet mask given using VLSM, it will change. So because the block size is 128, meaning the mask will be /25, as you can see from our VLSM table. So because it's /25, what's the subnet mask at the end? It's 128. So it's 128 at /25. So That's how you can represent the subnet mask. Now, after knowing that, we need to know the IP address range. IP address range, which is really necessary for subnetting using VLSM. So IP address range, because students, the first one being subnetted, will start at .0. So .0 will be our start, then where are we ending? So we need to add this block size, which is 128, on this initial start, which is 0. So 128 plus 0, it's 128, but minus 1 to maintain the network address and broadcast address, we get 127. So basically this represents the network address and this represents the broadcast address. Now we need to know the default gateway. So default gateway basically is the next IP address after the network address, meaning it will be .1, because this is the network address and this is the default gateway now, which is the next IP address. Now that we know that, let me explain some things. Okay, so we said we can have 120 hosts. So why is that so? If we say -2 for the network and broadcast address, this is the network and this is the broadcast. So if this is the network, we will count this IP address as 1 and the remaining 127. So 1 minus 127, that's 126, giving us the valid IP addresses we can assign to a device under students. So there are 126 IP addresses available for 120 members, which is just okay. So no wonder we are using VLSM. We are trying to accommodate the number of people to be assigned with an IP addresses on their devices. So that's the main use for VLSM. Now we'll continue. So what I'll do is this: I'll copy this information, then paste it under general admin. So general admin has 43 members. So which block size can accommodate 43? As we can see, it's 64. So 64, if we say 64 minus 2, it's 62, which is giving us a huge number to accommodate 43. So if it's 64, the block size, we'll just say 64. To know the number of valid hosts, we know it's 64 minus 2, as I said, which is 62. Now, since we have 24, which has a /26, and the mask is 192, we just need to change this. So to 192, then /26. That's how we can represent the subnet mask. Now, here we ended subnetting at 127. So the network address for this one should be 128. Then we remove this. Now, same procedure. 64 plus 128. That's what we need to do for us to know where we'll end with this subnetting. So I'm just opening up my calculator. So it's 64 plus 128. So 128 plus 64. So that's 192. So we are ending at 192, but I won't write 192. I'll say 191. So minus 1 to maintain the network address and broadcast address. Why are we doing this? Because 192 will be the network address for the central admin now. So I'll pause the video to save time, so that now I just subnet for the central admin and show you. Okay, so the default gateway for general admin is 129, because that's the next IP address after the network address. And for central admin is 193, because that's the next IP address after 192. So basically default gateways are just there to know where to deliver packets using a router. So now that we are done subnetting, it means that you can tell that it's VLSM, because the subnet masks are different from one to another, so they're different. So no wonder it's called VLSM. Now we just need to show this implementation and how we can apply it. So that's what we'll do now. So if you can remember, the question says that we need to employ efficient use of network resources, including the IP addresses. So efficient use of the IP addresses was basically done using VLSM. So we are not wasting IP addresses, because we are giving out or assigning IP addresses to a specific number of members we need from those departments. For example, 17 members can only have 30 IP addresses which are being used, because the block size was 32. Unlike static, whereby if the block size is 128, even 17 members can use 126 IP addresses, which is not efficient. So for the IP addresses, we are done. Now for network resources, what we need to understand is that we only need to use one switch, so as not to make it expensive. So I'll drag one switch just like that. Then remember, we have three departments: students, general admin, central admin. So I'll do that 1, 2, then 3. So those are representing the departments we have according to the question. So this is just an implementation. Basically, you are not supposed to put it in Cisco Packet Tracer, but just to draw it. So these can be students, and this can be the general admin. Just make a decision, general admin, and this can be the central admin. Now for the connection, remember, if we want to make sure that these guys are under one local area network, we are using just one switch. Like you are seeing here, we are using one switch, meaning they are under one local area network. They can be communicating, all of them, they can be communicating, but because our subnetting is separate, what I mean, I'll give you an example, is this. If you see under students, if I include the devices such as PC0, it can have an IP address after the default gateway, which would be .2. So if the IP address is .2 for PC0, then I come into PC0 under desktop, then IP configuration, I paste that .2. So as you can see, the mask for students was 128. So here I'll put 128. Then after doing that, I'll put .1, the default gateway, which is .1. I'm done, right? Then if I go for general admin, so general admin, that's the default gateway 129. So if I go for general admin, then IP configuration, so this device can have 130, because 29 is for the default gateway, and if we check the IP address, it's 192 for this general admin. So here I'll put 192, then that's the default gateway. And lastly, we have the default gateway for this central admin, which is 193. So meaning this device can be given an IP address which is 194. So we need to check the subnet mask. So as we can see, it's 224. So after knowing that 2224, we need to put the default gateway. Now what I was saying is that These are more like they are on the same network, local area network, but they have different networks. So if I try to ping, if I try to see if students can communicate with maybe the general admin, which is this, can communicate with the general admin using that IP address of the general admin, which was .130 for that PC. You see that they cannot communicate. So it's what 10.130. Why am I writing .40? Anyway, let me just write .40. Okay, then try to see if they can communicate. So as you can see, it's writing timed out. Even though I try to see if the students can communicate with the central admin, which is .194 for that PC. Let me do that. So just press up to bring back the previous commands, then change it to 194. If you want to see if they can communicate, still they won't communicate and it will say request timed out. So why is that so? The subnetting is correct, but they cannot communicate. Your subnetting has made this local area network to have different networks. Therefore, we need a router, just one router, which will be doing, we just need one router such as PT router, which will be in charge for routing these packets now. So this router, I'll just connect it on the first interface, one, then here also one. Then now this router will be in charge to deliver packets to these other PCs, but the issue is that it only has one interface, which is FA1/0, which can have an IP address for only one network. So we need to create VLANs on this switch. After creating VLANs, now we need to create sub interfaces which will have every default gateway for students, general admin, and central admin, so that routing or intercommunication can take place. All right, now that we know that, let's go ahead and create VLANs for this switch, then see how it is. Okay, so basically VLANs are just what we call virtual local area networks. So it's more like you have a normal local area network like this one, but you want to create a virtual local area networks to increase the security, so that these guys cannot be communicating, but that is already happening because of the subnetting. But again, VLANs will help us demarcate this router to each specific department using port numbers, and after that we'll create a trunk port which will allow this route and switch to deliver packets to the intended device. So first thing, when you go into your router, you need to say en to enable, then conft. After that, to configure terminal, you can say VLAN. So we cannot start at VLAN 1 because VLAN 1 is the default, so we start at VLAN 2. After saying VLAN 2, you give it a name such as students. After doing that, you say VLAN 3, the next VLAN, you give it a name, so the name such as general admin. General admin. Now, after doing that, you go to VLAN 4 and you give it a name, so that name will represent central admin. Now central admin. Now that you have done that, once you paste these commands, it means that you have successfully created your VLANs. Now we need to assign them to a certain port number. So you say int for interface fa 0/2, which is this interface from the switch going to the students. So that interface, you say switch port access or mode, then access. Again you repeat switch port access, so VLAN. So now students is VLAN 2, so you say VLAN 2 for students. So we need this port to access students, such as here as it is. So I'll do the same thing for the remaining central admin and the general admin. So I'll pause the video, then assign them to that, then continue. Okay, now that that is done, all I need to do now is to create a trunk port. So the simplest way to do is that you just need to know the interface for this trunk from that of the switch. So as you can see from the switch, it's FA0/1. So here to be /1, instead of saying switch port mode access, we'll say trunk. So after doing that, you are assured that you are done with the commands, so you can copy them, then paste them into your switch under the command line interface, which is CLI, then enter, paste. After paste, another enter, you see that everything will initialize. So this is just off, otherwise it was supposed to turn into orange. So turn it on after we have started the commands for this one. So that's how you create now VLANs. If you want to check, you can just come on the switch. You can see VLAN, the first port has 2 dashes under VLAN, meaning there's a trunk. Then second port, it belongs to VLAN 2, third port belongs to VLAN 3, fourth port belongs to VLAN 4. The remaining ports are for VLAN 1, which was for the default. Remember I said we need to start at 2. Now let's create the sub interfaces now. So let's do that. So before we start the commands for the sub interfaces or sub interface, we need to understand one thing. As I said, if we go under this router, we cannot put under config, we cannot use this port, which is F1/0, to put 3 default gateways under this IP addressing tab. So all I can do is just to switch it on, then create sub interfaces which will know these 3 different types of default gateways. So that's why we are doing that. So now once you click on your router under CLI, you say en conf t, which is configure terminal. Now you need to know the interface. So the first interface, as you can see, the main interface from the router is FA1/0. Now we have VLAN 2, no wonder we are saying .2 to represent students. So basically we will say encapsulation .1q. So encapsulation is just a protocol which is just there to encrypt something during its transmission. But this protocol in Cisco Packet Tracer, it's based for routing. So encapsulation .1q, and then you say 2 because we are at VLAN 2. So we will say 2, then IP address. Now the default or IP add, the default gateway for students, because that's VLAN 2, we go under students, then we get this default gateway, which is .1. We get that default gateway, we paste it here. Then again we go under students, we get this subnet mask without /25, then we paste it just here like that. Then we can say end because we are done, then WR to save our configuration. So I'll repeat this same process for the coming general admin and central admin. Now that everything is done, I'll just copy these commands, then go into my router under CLI. I'll make sure I'll exit this, another exit, Okay, now I can paste those commands, then enter. So the moment I do that, if I go back on my PC0 to see if it can communicate with the general admin and students, I'll just do this. So here I'm trying to see if it can communicate with the central admin. If I get some TTA or replies, it means that now they can communicate. So as you can see now, they are communicating with the central admin. Now let's see if they are communicating with the general admin. I'll do that .18 for the general admin. Yeah, so now we see that students can communicate with the general admin and the central admin. So now that we have done that, this means that we have used the resources efficient, because we require only one router for routing. We require just one switch for the VLANs, and these PCs, one piece is just for demonstration. So that's the answer for that question. But now let's talk about one more way of subnetting. Okay, so remember we had this first method. So the other method that they usually teach the lectures, I learned that method from Mr. Chiara himself. So here is what we do. There's what we call a subnet. A subnet which has a formula of 2 to the power x. 2 to the power x, whereby x represents the number of ones in a network. Then we have hosts, whereby the formula is 2 y 2 to the power y 2 to the power y minus 1, whereby y represents the number of zeros in a subnet or an IP. So number of zeros, and from that we have what we call block size itself. Block size. So basically block size, what we do is we say 256 minus the subnet mask to know the block size. So that's the formula. So with these three, you can come up with that VLSM table again, then do the subnetting as we did. So I'll just give an example with few things. If we want to know the subnet, for example, let me say we have a block size of 32. We have a block size, not a block size, but we have an IP address which is 255 subnet mask 255.255.240/28. I'm getting this information from me like that. So now if we're given such an IP, first thing we need to know is that why is it /28. We know that there are 28 ones according to this, right? But now what we need to do is that under this subnetting, how they came up with this, we have what we call a power of 2. So you need to ask yourself, what's the power which can give me 128? So which can give me 28, by the way, or 240. So if I say 2, let me just go. Okay, so if I know that there are 28 ones in this network, and I know that this is 24, now how many bits are remaining with it to get 28 to if you have 24? So it's 4. So I will say this 2 because network host part will have 4 bits now. I'll say 2 power 4 to know the subnet, so it will be 16. So the subnet for this subnet for this above thing, it will be 16. So if the subnet is 16, how can if you can see 16 is here just like that. So if the subnet is 16 now, how can I know the block size, or without using this formula? Basically, we know that we have 256 for all the bits, 256 the rest power. So if we divide that by 16, which is our subnet, what 256 256 divide by 16, oh sorry, so we have this formula and we have 240. So if you want to know the block size, basically what we need to do is that we have 256 minus 240, which is giving us again 16. So no wonder the block size it was 16, as you can see. Or you can do the same thing as doing, which is 256 divided by 16, which is just giving you 16. So basically the subnet and block size are more like the same in this situation, but I'm not saying they're the same. So after knowing that, we can go to the number of hosts using this formula. So y represents the number of zeros. So in a case whereby we said we have 24, we have 28 ones, I'll just do this. We have 28 ones, like 1 2 3 4 1 2 3 4, meaning if we have 28 ones from that subnet and we only have how many zeros? 4 zeros again. We only have 4 zeros. So if I compute this formula, which is 2 power y, meaning 4 zeros, power 4, it will give me 16. Then minus 2, not minus 1 here, I'm supposed to say minus 2. Minus 2, I'll say that's 14. So there can be 14 valid hosts for this. So same thing as we said before, if you have a block size, you just say minus 2 to know the number of hosts. So that's the thing. So this is another method. Then you can just continue with the subnetting itself. So thank you for watching. This is Soko James, cybersecurity student at Kapasa Makasa. Hope you enjoyed.